about 500 meters in diameter. We inferred its shape from our radar data that we took when it came by in 2000.
A spacecraft on a U of A-led mission to collect a sample from an asteroid arrived at its target this week.
We have arrived.
Scientists celebrated the arrival of OSIRIS-REx at the asteroid Bennu. This moment was years in the making. You'll remember the unmanned spacecraft launched back in 2016, and it won't return to Earth until 2023. We learned more about the mission's next steps from image processing lead scientist Danny Dell'Agostina. How would you describe Bennu? What are some of the characteristics of this asteroid?
So Bennu has an unusual shape. It has a kind of spinning top shape, so around its equator it kind of bulges out a little bit. And it's about as large as, for example, the Push Ridge Wilderness. If that gives some people in southern Arizona a visual cue. Or you could also think about it as about as tall as the Empire State Building. It's very dark. It's approximately the same darkness as coal, so it only reflects about 4% of the sunlight that encounters its surface. And what we've been learning throughout this approach phase leading up to arrival at Bennu is that its surface is pretty rocky. So it has a lot of boulders and material that we're going to need to avoid when we eventually choose a sampling site on the surface.
For the next year and a half, OSIRIS-REx will continue to collect data and images of the asteroid. It will help scientists select a site on Bennu where the spacecraft can collect samples from.
We don't actually land on the surface when we take a sample of Bennu. We just slowly descend and what we call a tag maneuver or a touch and go maneuver. We collect the sample and then we back out and we move to a safe distance from the asteroid to confirm that we've actually gathered something and achieved mission success. So one thing that is really cool and unprecedented is just how high resolution we are mapping the surface of this asteroid. By the end of the phase of the mission where we're evaluating the 2 different candidate sample sites, we'll be able to resolve an object the size of a penny on the surface of the asteroid.
Now this is the big question. What are you hoping Bennu teaches you and us about how we got here?
So very dark primitive asteroids like Bennu are thought to contain some of the precursors for life. So they are rich in organic materials, amino acids, water, and there's even some ideas that the water that we have here on Earth was delivered by asteroids like Bennu. So as we study its surface and its composition, and then we bring a portion of its surface back to Earth, we're really hoping to confirm that maybe perhaps these asteroids provided the building blocks for life on Earth and potentially throughout the solar system.
Okay, let's fast forward to 2023. That's a date that you're anxiously looking forward to. Take me there. What do we expect then?
So in September of 2023, OSIRIS-REx will have completed its journey back home to Earth after acquiring a sample, and that sample will get delivered to a test range facility in Utah. And so at that time, the OSIRIS-REx spacecraft will release the sample return capsule. It'll make its way down to the Utah test range, and there will be a group of scientists and engineers there ready to collect that sample and make sure that it's safe and bring it to our sample curation facility at the NASA Johnson Space Flight Center.
A mission like this certainly puts the University of Arizona, or keeps the University of Arizona, I should say, on the map, right?
That's right.
Okay. Can you give us any insight into the significance of the university's involvement and what this could mean for future exploration?
Yeah, so the University of Arizona was the first public university that led a mission to Mars, and that was during the Phoenix Mars mission. And now we're going to be the first public university to lead a mission to an asteroid. And so it's unprecedented for public universities to carry the flag in these sort of grand scale planetary exploration efforts, and it provides just unparalleled access to opportunities for the students here at the U of A. And I mean, a lot of the experience I gained as an undergraduate here at the University of Arizona is what enabled me to have a career in the space sciences, and so I'm very happy that we can pass that on to the next generation.
Okay, well said. Thank you so much, Danny.
Thank you.